Okay, continuing with section 6.2, example 4. Okay, in example 4, you're being asked to rotate to a location of +4, -3. They don't mention an angle, so this is just, there's two different ways for them to tell you. There's actually three different ways. In this particular outline, they either tell you what angle to rotate to, or they'll tell you the X and the Y quadrant, as you had several of those on pages 1 and 2. So here's going to be my picture. I'm going to rotate to a point on a circle called +4, -3. So again, remember you have double positives in this quadrant, negative x's and positive y's here, double negatives here, positive x's and negative y's here. So for you to go to a positive x and a negative y, that would be on this side for positive x's, down here for, so you could say that right here on the circle, you are at 4, -3. This just represents a point on a circle. Okay, then you travel from the point where you're digging into the circle up to the nearest x-axis. The 4 that you see here represents the horizontal leg. It is the x value. This horizontal leg represents the x value. The leg that runs up and down is represented by this y coordinate. So you would put the -3 right there. Don't forget the hypotenuse can never be negative. Now, you see that this problem has nothing to do with the zeros and ones, and it also is not a special right triangle. So since it's not a special right triangle, it's neither 30, 60, 90 nor 45, 45, 90. Your only recourse for getting the hypotenuse is to do Pythagorean theorem. So that's how you're going to go about getting this last missing piece. Now let's see what we're being asked before we go too far. Draw a diagram, find the values with all sides. Okay, so we're going to complete this by doing Pythagorean theorem. That goes hypotenuse squared is equal to leg squared plus leg squared. Okay, hypotenuse, we can just call it r. It is the radius of the circle. The legs are, and you might have this memorized, what this value is. If you do, then you don't have to calculate it using the Pythagorean theorem. So this would be 9 plus 16, which is 25. That's r squared, and if r squared is 25, you would then take the square root of each side, leaving you with r equal to 5. Okay, so we've completed the diagram. And now in part B, we're going to find, let's see, what else do we have to find? Draw a diagram before finding the values with all sides of the right triangle. Okay, no, we have, in part A, we have to go on to find all 6 values. Okay, so now that we have everything, we're going to do cosine, which is x over r. That's the definition. Again, this is the x, this is the y. So x would be 4 over 5. I'll go ahead and do the secant, which is the reciprocal to this. Just flip that over, and you now have that answer. Okay, next I'm going to do sine. So its sine is equal to y over r. Y value is -3. R, as we calculated, turned out to be 5. Third answer, and then we'll do the cosecant, which is the reciprocal of sine. So just flip that over, and you can put the negative at the top or wherever it is that you want to put it. Okay, and then the last 2 values that we haven't calculated would be tan and cotan. So tan is y over x. which is -3 over 4. And the cotan, it's nice when you don't have any radicals because you have no rationalizing to do, is 4 over 3. And you can put the negative at the top or the bottom. Okay, those are all 6 values. Okay, likewise for part B, you have not been told what angle to go for, but you still know what quadrant you're in because you have a -x and a -y, which can only be in quadrant 3. So again, here's your circle. You're going to go -6, -8, and be somewhere down here. So we'll just call that dig-in point the actual point with the x-coordinate of -6 and a y-coordinate of -8. From that point where your rotating arm, which is this hypotenuse right here, your terminal side, you can go from that point to the nearest x-axis, which would be the negative x-axis. This -6 gets assigned to the horizontal leg, little mini looking x-axis, and this y-coordinate gets put right here. So the vertical leg is always the y-coordinate. Okay, then in order to get the hypotenuse, just like you got it in part A, for part A, you can do Pythagorean theorem. So it's hypotenuse squared, we'll just call this R for right now. Hypotenuse squared, you have the formula in part A, is equal to leg squared. You want to keep that in parentheses so that you remember to square the negative as well as the number. And then the other leg is -8 squared. This gives you 36 plus 64, which is 100. Okay, so you have R squared is equal to 100. Take the square root of both sides so that you have R equal to 10. Okay, now you have everything that you need to go ahead and get all of the trig values that you need. Okay, so they want all 6 trig values just like in part A, so it's cosine. You can put the angle here if you want, but really you would just only be able to call it theta. And you can just jump into the definition, which is the most important thing, that you understand that this is defined regardless of what this angle is or regardless of whether you write it, it is defined as x over r. So the x value on the picture is -6. Remember, your r value is never negative, always positive. And then you can reduce this. 2 goes into the top 3 times, 2 goes into the bottom 5 times. So that's your cosine. Your secant would be the reciprocal. So I'm not going to bother to write the definition. It would just be 5 over 3, put the negative top or bottom. Then it is sine, defined as y over r, which is in the picture is, here's your y, the -8, the r is 10. Reduce it, 2 goes into the top 4 times, 2 goes into the bottom 5 times. And then the reciprocal of sine would be cosecant. You flip this over, and you get 5 over 4. Last two, tan and cotan, which I guess I will do right here. So tan would be equal to y over x. So that's going to be -8. This is the y value over -x. Reduce that, and you get 2 goes into the top 4 times, 2 goes into the bottom 3 times, and that's your tan value. Your cotan would be the reciprocal of this, so 3/4. And that's all 6 values. So both 4a and 4b are examples illustrating the Pythagorean theorem. Okay, then when you get to example 5, you have actually a triple problem here because You're going to have to figure out the sine of 30 degrees, the tan of 30 degrees, and then once you get those values, you're going to go and plug it back into the scenario that they've put forth for you here, where they want you to get this value, multiply it by 6, get this value, multiply it by -3, and combine those two values. So this is 180, in case you don't know why I'm saying 30. 180 divided by 6 is 30 degrees. We're going to draw a picture at 30 degrees. This is also 30 degrees. So you're going to draw a picture at 30. So this arm is at 30 degrees, which means this reference angle's at 30 degrees. In quadrant 1, by the way, quadrant 1 is the only place where when you draw the triangle, the right triangle, this rotating arm called the terminal side, it will be the same as the reference angle, but that will not ever be so again if you're in quadrant 2, 3, or 4. The reference the spinning angle called theta and the reference angle won't be the same if you're in quadrant 2, 3, or 4, but in quadrant 1 it is. Okay, 30 degrees, you have a short leg value of 1. That'll represent your y coordinate. You have a long leg across from the 60. You can look at the formulas that I gave you on the first page of this outline, where it says you can arbitrarily choose any value you want for your short leg across from the 30. Your long leg will always be the short leg times square root of 3, and your hypotenuse will always be double the short leg, and always positive. So now come back here, and you're going to do, you can do them over here first if you want to, and then bring it back to this shell. So it's the sine off of this 30-degree picture that you've just drawn, which is y over r. That would be 1 over square root of 3. Then, in order for you to plug this in and be able to use it easily, you're going to want to rationalize this 1 over square root of 3. So multiply the bottom as well as the top by square root of 3. That'll give you square root of 3 over 3. Okay, so this is equivalent to this. So as some students have asked me, do I ever see this again in the problem? No. When two things are equal, this is equal to this, you can replace one for the other. So instead of seeing the trig word and the angle, this entire expression is now gone, and in its place, sine of 30 degrees, you can put its equivalent, which is square root of 3 over 3. Now it is being multiplied by 6. So we'll do that arithmetic in a minute. Now let's do tan. I'll do tan right over here and then bring it into the problem. So tan at 30 is y over x. Okay, the y is 1 and the x is, let me make sure, yes, I think what I actually did is, oops, I'm going to have to switch these around, sorry about that. When I went to do sine of 30, it was y over r. What I actually calculated here was tan. I did y over x. Let me switch this. Sorry about that. So this was y over x. That was the tan that I was just about to do. So we'll just switch that. There's my tan, and I'll let this one be the sine. So tan will be y over x, just switching that since I already did all the work for that. And then this will be the sine, which I also needed. Sorry, I messed that up. Sine of 30 is y over r. So that y value would be 1 over 2. Okay, so this is your sine value, this is your tan value, and then you go and plug these values right in here. So since I made that correction here, my sine value was 1/2. Put that right in here. and then it's going to be 3. Your tan value is going to be right here, square root of 3 over 3. And then you're just going to reduce this. This is the same thing as 3 over 1. This is the same thing as 6 over 1. So this is 6 divided by 2. 6 divided by 2 is 3 minus, this 3 cancels with this. Square root of 3 over 1 is square root of 3. Okay, last one is 510. It's the last one on the outline. You're going to rotate to 510. So you can, be thinking that one full rotation is 360, and then you can figure out how much more do I have to go. So if you already went to 360 by doing a full rotation, what you could do is just go 510 minus 360 to figure out what the additional movement needs to be. 510 minus 360, and you have 150. Okay, so on top of this, you need to go an additional 150. This being the 180 mark, that would mean this would be the additional 150. So 360 plus 150, you are at 510. Drop down from here to here. If you just went an additional 150, that would mean this is the 30. This would be your short leg. Hypotenuse is double. Long leg would be across from the 60 that's up here. That would be square root of 3. And this picture is drawn in a quadrant where the x's, that's this leg right here, are negative. The y's are positive. Hypotenuse is always positive. So when they say do the 6 trig functions, it's cosine. You can write what they originally gave you, which is 510, but this picture represents what happens at 510. So you can write the 510, use the definitions that I gave you in class. So it's x over r. Flip that over in order to get secant, which would be 2 over square root of 3. You can put that negative again wherever you want. I'm going to keep it at the top and rationalize it. So 2 square roots of 3 over 3 with the negative at the top. Then sine of 510 would be y over r. So the y is the 1, the leg that runs up and down. The r is 2. Cosecant is its reciprocal cousin. So you just flip that over and you get 2 over 1. So there's the third, fourth answer. Last two. Tan at 510 is y over x. So 1 over square root of 3. And that negative is right there, but you can float it to the top and rationalize at the same time. So the square root of 3 over 3, it was negative. And then for cotan, you're going to need to flip that tan value over. And you might want to flip it over before you rationalized it. So just flip this part over right here. So square root of 3 over 1. When you flip something over, that does not take the negative away. So that negative is still there. So that's the final answer. And that concludes the entire outline for section 6.2.